track of advanced coastal and offshore engineering. A very good evening and welcome to Iccoee 2020. You are now in the team track of advanced coastal and offshore engineering evening session. I am Zahira Niza Mustafa, the chairperson for the session today. We are going to hear 8 papers, and we're going to start with the first paper by the name of Response of Corroded Offshore Structural Plate at, at Top Sites Due to Blast Loading, presented by IR Dr. Muhammad Mubarak Abdul Wahab from University Technology Petronas.
To blast loading. For today, this is the outline. A very good day. I bid to the audience. Thank you for listening to my presentation. Let me put my screen on slide mode. So I am Mubarak Wahab from University Technology Petronas Offshore Engineering Center. My topic is response of corroded offshore structural plate at top sites due to blast loading. For today, this is the outline of my presentation. Going into introduction, we know that offshore platforms are typically put on harsh environment and it deteriorates during the period of operation. For about 20 to 25 years is the typical lifespan of the platform. Corrosion is a common phenomenon. It reduces the strength of structural elements, and blast in offshore platform is a hazard, and many accidents has been recorded in the past, mostly at topside elements. Offshore platform design must meet safety requirements subjected to extreme loading conditions, and blast is one of the vital and generating most impact in that extreme loadings. Important to know the response of an offshore operating an aged offshore topside structure that has undergone corrosion subjected to blast loading. Possible accidental explosion could occur. Numerous studies on the effect of blast loads on imposed on non-corroded structures, but very less on corroded structures or with a blast load. So in this study, we represent the offshore platform structural element in a plate element, and the objective is to evaluate the deformation of the corroded plate under blast load. Abacus software is used for this study, and detailed parametric study was utilized to study the deformation of corroded plate under the influence of degree of pitting of corrosion. And we have utilized different corrosion patterns. Pitting corrosion is a localized form confined to a small area and grows in the gravitational direction. For this study, a simply supported rectangular steel plate subjected to blast load was studied, modeled and studied. Looking at the literature, blast load is categorized as a temporal and spatial pressure distribution. Rises with time, maximum pressure and pulse duration are the temporal parameters, and the pressure is considered uniformly distributed. Response towards blast load may either be determined by nonlinear dynamic FEA or by simple calculation. FEA stands for finite element analysis. Both methods should be based on single degree of freedom, analogies and elastic plastic method of analysis. Blast response is classified into 3 domains: impulsive, dynamic and quasi-static. And these are the functions in the table 1. You can see these are the functions typically utilized or utilized in this study as well. These are taken from the literature. And looking at the past studies, we can highlight a couple of studies done by researchers recently. One, for example, looking at transient response of stiffened plates subjected to underwater shock loading. They were investigating the displacement time histories of plates under different shock loadings using FEA. And another study on experimental and numerical studies on rectangular plates subjected to underwater explosion. They were looking into strain rate considerably affecting the deformation time history. Another study on parametric study on different degree of vulnerability of each structural component under blast loading. looking at dynamic and non-linear effect of the study. Uh, Pitting corrosion as a localized, confined to small area, growth in gravitational direction was studied by some authors as well. Plastic collapse load or corroded steel plates under tension in plane compression and buckling was studied on simply supported plates with one and both sides of corroded surface. Um, and also ultimate strength evaluation of corroded plates using FEA was looking into damage increase, ultimate strength degrades, effect of shape distribution and depth of corrosion pits on the ultimate strength. And this is the parameters utilized by the author in that study. Coming to my study, we have modeled the blast and as an impulsive form. Following this model here, you can see on the table, it was linear increase to 2.5 bar, and the pressure is maintained for a certain period of time and come down to zero again. In all this happen in a very small time frame, 0 0.1 time second or 100 millisecond. And the plate is modeled as a 10 mm thick plate with a breadth 600 by 600 square plate. The aspect ratio is 1, slenderness ratio is 60, and no any geometric imperfection or welding induced residual stress are modeled. It is a simply supported boundary condition plate. 3D deformable shell element and solid and homogeneous section is the model. The corrosion is modeled as cylindrical pit with a diameter of 30 to 40 mm, located at plate surface pressure phase. Corrosion pattern on one side of the plate only. Material properties as assumed as according to the previous table 2 I have shown earlier from the literature. The amount of corrosion is measured in a ratio called DOP. This corroded area over plated area. Is a DOP is a degree of pitting. Yep. And also many other ancillary or subsidiary, no, like supporting conditions mentioned in the plate. So coming to the results. So when we see the results, when we analyze that plate with a couple of different degree of pitting and the affected to blast load, even the blast load was varied in a different milliseconds. And since the plate is quite big, 600 by 600, and we try to minimize the modeling effort by having a symmetrical model. So we try to analyze the model in a quarter of the actual size, and you can see the different frames, figure frames showing the different degree of pitting adopted in terms of the pattern on the physical position of the degree of pitting, as well as the diameter of the degree of pitting. And the graph here showing about the results obtained in terms of percentage of deflection measured according to this formula here. Uncorroded deflection minus the corroded deflection. Sorry, corroded deflection minus the uncorroded deflection over the corroded. So this is how we obtain the percentage of deflection. When we look into percentage of deflection over the different degree of pitting, the one on the left bottom axis is the smallest, the one on the right is the highest. We can see a bit upward trending pattern up to a certain extent, and suddenly there's a big jump between these two colors, the maroon and the green, which is actually the 22.4 percentage to 28 percentage. There's a vast jump in the deflection percentage, and after that 28.28 percentage, we can see it is going gradually downwards. So this is a bit interesting fact that we have found. And number two, when we look into the stress distribution and deflection over time, also regard to the different degree of pitting, we can see a bit interesting find. This we have compared with the control with non-corroded plate, and we can see some obvious pattern, especially on that the blue line, purple, and the orange line here. and also the same blue line, orange, and the purple line here. So we can see a stark difference in terms of the deflection magnitude, as well as the stress distribution pattern by time. So what we observe here, in a higher DOP, steel plate geometrical surface has become too irregular for the stress. Also loss of strength to be distributed throughout the plate element, hence higher deflection. So this happens actually in a higher degree of pitting. The plate become too irregular for the stress distribution, also to take the load, so it has lost its strength. And because of that, we observe higher deflection in those higher degree of pitting. Yeah? You can see especially the 42.35, 35, and 28. So this is the obvious result we have obtained. So to conclude, deformation of the plates under the influence of degree of pitting is observed. Deflection of the plate increases with increasing DOP, but having two major patterns as I described just now, and stark difference at certain extent, especially when the percentage of degree of pitting increases, and we have sudden increase in the deflection. Plate with DOP 0.35 percentage to 12.6 percentage has lower deflection. This is what is a good finding, is this is the degree of pitting we can allow for to limit the deflection. Higher DOP in steel plate geometrical surface has become too irregular for the stress, also loss of strength to be distributed throughout the plate element, hence the high deflection. So with that, these are the references we have referred to for this study. With that, I thank you for the time and the attention. I am stopping my presentation here. Thank you.
Thank you very much, Dr. Mubarak. It was a very nice presentation about corrosion on the steel plate for offshore structures. So
Thank you.
for audience, do you have any question? You can post it now. But for now, we have one question. Dr. Mubarak, what would be the optimum allowable corrosion that from your findings that you may want to advise to the industry
All
before it
right.
gets worse? Yes.
Thank you. Thank you for the question. So this is a study done on a plate, and based on the plate, because we have corrosion allowances for other tubular members and other structures. For this plate, it was purely a parametric study, and when we have done it, we have found that there are, and even the measurement of the corrosion is in the degree of pitting ratio indicator, and which is like the area of the plate and the area of corrosion you have, with a certain amount of magnitude of corrosion, the depth of the corrosion. So from this study point of view, we can say that we have found that there are certain percentage, like below 3%, it's still behaving better or even similar to the without corrosion, plate without corrosion. So probably we can say, we can make a conclusion, because this is a part of the bigger study, corrosion model study, and we can make a conclusion, brief conclusion, that you can have up to that extent, 3 point something or even 4% degree of pitting before you can see some other consequences to the other mechanical properties.
Okay. Okay. Okay, Dr. Mubarak, thank you very much. I think we lost your image for a while there, but we could get the points you just shared. Thank you very much, Dr. Mubarak. Okay, ladies and gentlemen, we are going to listen to the second paper presentation today, entitled Interaction of Wave-Induced Motion and Bioelectricity Generation for Floating Micro or Algal Biophotovoltaic System. A very unique name. We have with us today Mr. Chin Jia Chun from University Technology Malaysia.
A very good day to my audience and fellow friends. First of all, I would like to thank you ESCOM 2020 give me a chance to present my paper. My name is Chin Jia Chun and I come from University Technology Malaysia. Today I would like to present my paper with a title of Interaction of Wave-Induced Motion and Bioelectricity Generation for Floating Microalgae Biophotovoltaic System. And let me introduce my co-authors. That is Dr. Iccoee come from University Technology Petronas. Dr. Iccoee Ps2 come from Malaysia, Japan International Institute of Technology. And also Prof. Dr. Lee Kia Moon and Mr. Tae Wayan come from UCSI University. And my co-supervisor is Prof. Dr. William Chong Wei Fong and my supervisor Dr. Kang Huai Xiang come from University Technology Malaysia. And is my presentation outline include introduction, literature review, experimental session, and result and discussion. And introduction: human development leads to increased energy demand. Global energy and CO2 status report 2018 stated the world energy consumption grew by 2.3% true to the rapid economic growth of 3.7% in the year of 2018. And also in the National Energy Outlook 2019 estimated the world energy consumption will rise by more 50% from the year of 2018 until the year of 2050 through to the development of non-OECD countries. OECD is the short form of Organization for Economic and Cooperation Development. And so it is necessary to find out a new energy source for continuous human development in the future. And I will talk about something that I did not mention in my paper. That is the potential of algae industry in Malaysia. Malaysia possesses great tropical sunshine, long coastline, enormous diversity of algae, and sufficient infrastructure that provide our country natural dominance in the development of algae industry and related technologies. And so it has resulted in an aspiration of building a 5 billion annually global microalgae consumption industry in our country. And one of the outcomes is the opening of the world's largest microalgae cultivation facility since August 27, 2019 in Kuching, Sarawak, as you can see in this figure. And I will talk about the objectives before I go to the introduction to build photovoltaic BPB. First, to assess the feasibility of a floating BPB by using cyanobacteria as a power source. And second, to determine the power generation of the BPB in a floating state by benchmarking with a static BPB. Introduction to BPB. Pure photovoltaic is a relatively new type of pure electrochemical systems that utilize the microorganisms such as bacteria, cyanobacteria, and microorganisms and microalgae as an electron source to drive current flow. It can eliminate the application of external microbursts to simplify the system and reduce operating costs through the catalyst. And BPB functions through redox reaction. The photosynthesis of the microorganism will result in photolysis of water. And photolysis of water will produce oxygens, photons, and electrons that can play a vital role in the energy production of the cell. And the excessive electrons will transmit to the external environment to drive current flow. As you can see in this figure, the electrons released by the photosynthetic material will absorbed by the anode and transmit to the cathode to drive current flow. And period studies is a table that shows the period studies of static BPB. And for now, the highest power density is recorded in the research of Sa et al. In the year of 2018. The maximum power density of 530 milliwatt per meter square is recorded in the research by using cyanobacteria mutant. The cyanobacteria mutant is created by genetic technology that has higher ability to release electrons to the surrounding environment as compared to the natural cyanobacteria. And I will talk about the benefits of floating BPB. Floating BPB transforms traditional land-based BPB into free floating structure by utilizing floating technology. And microalgae need a large surface area for sunlight absorption to promise optimal power output that can result in wasting the precious land resource. However, floating BPB can turn the uncommercial ocean surface into solar power plant to solve this problem. And also, wave motion can enhance mass transfer and mixing efficiency between the nutrients and cyanobacteria or microalgae. And so, an increment of 50% of the microalgae biomass production can be observed. And it will result in it will result in higher power output of the BPB device. And then you can see the figures of the illustration of floating BPB and also floating BPB on sea surface. And I will go to the experimental section. Spirulina pendensis is chosen as the electron source in this study. This is a kind of cyanobacteria. It is cultivated in a sterilizer container under room temperature and stabilized source. And Zaro medium is used to provide nutrients and maintain the inner current. And for the BPB model, two chambers BPB with a dimension of 16.5 cm length, 11.5 cm width, and 8 cm height is fabricated as you can see in this figure. It's connected by the stoppage. The chamber is connected by a stoppage. An experimental schedule. 150 milliliter of cyanobacteria medium and distilled water are filled in the anode and cathode chamber respectively. And the main components of the floating experimental schedule include the bell-driven linear actuator. They move at a constant frequency to modify regular wave and to trigger sloshing of the medium. And the DC motor that provide momentum to the system. The rotary encoder to record the displacement of the linear actuator and maintain the accuracy of the system. And Arduino Uno board with a 3-turn controller to provide general control to the system by using coding and procedures. The procedures of the experiment. BPB is autoclave to remove microorganisms and bacteria. And a light source is provided for light condition. And for floating BPB, the experiment is conducted under regular wave motion that can be modified by using this experimental schedule. And equation. Current density, power density, and power efficiency is recorded in this study. For the power efficiency, the power production by the device per meter square is divided by the solar power absorbed by the device per meter square. And result and discussion. Power output is highest in steady light conditions, followed by steady dark conditions, and then floating light conditions. And more electrons released in light condition. Wave-induced motion reduces the power output of the BPB model, and BPB produces electricity in both light and dark conditions. And this is a table that shows the data that I record in this study. And it has provided a difference in power density for steady and floating BPB under light condition that has been displayed in red color. And this is the figures that show the BPB model for light and dark conditions in this research. And power efficiencies. The power efficiencies of the model is relatively low. Further improvements are necessary. As you can see in the table, a maximum power efficiencies of 1.788 is recorded. And below is the figures that show the experimental schedule with the real condition. And I will go to the conclusion. As a newly introduced study, there is a lack of relevant studies of the interaction effect of wave motion on the power generation of BPB. And this research developed a floating BPB prototype to explore the influence of wave-induced motion on the power production of the BPB through experimental study. And this is my reference. And thank you.
Thank you very much, Mr. Chin. It is indeed a very nice and new technology towards energy efficiency, yeah? And you have done it in the lab. So what are you proposing? Let's say if we want to have a higher optimum of energy efficiency or energy production, how can we do it? What would be your suggestions? Perhaps
My
the
suggestion
size.
is
Yeah.
just like what I introduced in the research of Sai, or he used the mutant technology to create a new species, mutant species in higher ability to release electrons to the external environment. So it will result in higher electron transmission. Also,
Yeah, that is good. I think at least that's one factor that we can play around. So, if we want to do it in the real world, uh, how can we start with that? Can we just
Okay.
have yeah,
Because the pure study is focused on the electron transmission from biopharms to the anode surface, and it will limit the application of the technology because the very large surface area is required for the growing of the biopharms. And so this is why we do it in a floating condition. Then we use solution technology to enhance the circulation of the medium in the cell chamber, and also enhance the electron transmission from different microalgae species to the anode surface.
yeah,
So we try to use this technology to enhance the power output of the system, and so it may be applied in the real world.
yeah,
If because my research is still running,
yeah.
the result I show is the early step, and now still running for
That's good.
the
That's good.
experiment.
Well, we wish you all the best with your research. We are sure it will bring towards something very, very outstanding technology. All the best to you in your research.
Yeah.
Thank you so much, Mr. Chin Jia Chun.
Right,
Thank you
thank
so much.
you, Dr. Zahira.
Okay.
Right.
Okay, so ladies and gentlemen, let's hear the third paper for today with the title Platform Conductor Integrity Management in Life Extension of Aging Offshore Wells. It will be presented by Mr. Loganandan Razakrishnan from University Technology of Malaysia and his team. But unfortunately today, Mr. Loga is not able to be with us, but you are free to post all your questions. We will be sending him emails, and we will get back to you once everything is okay. So for now, let's hear the presentation of Mr. Loga.
Hi, good day everyone. My name is Loga and my topic of presentation today is actually on the platform conductor integrity management in life extension of aging offshore wells. First and foremost, I would like to thank UTP and the organizers for this opportunity. Also, I would like to thank my supervisors, co-supervisors, and co-authors for this paper. Now, the presentation outline for today is actually the introduction, the methodology, the analysis, which has there are two, which is the number one is actually load on conductors. Number two is the strength and stability check, results and discussion, and finally conclusion. So, okay, on the introduction. In order to keep up with the energy demands and the volatility of the oil price, operators have been looking to extend the service life of their offshore wells. Severe corrosions on the metallic structures of oil wells consisting of the conductors and casings can result in catastrophic events leading to structural collapse. This paper describes the engineering methodology involved in the integrity assessment for platform conductor evaluation using analytical methods to assess the present condition of the conductor assembly based on the corrosion inspection data and existing seaman elevations. In cases where a physical repair is not possible, recommendations would be made for inspecting the anomaly for signs of worsening, conductor buckling, and material degradation. So, ladies and gentlemen, what is conductor? It's also known as a drive pipe. It's the external pipe which provides structural support for the internal well tubing and casing strings. Typically, this structure consists of several conductors and casing systems to support wellheads either for producing or other operations such as water injections. These offshore conductors are exposed to the marine environment, which leads to the significant corrosion of conductor pipe, which can lead to degradation of the structural integrity of the well, which may cause conductor collapse and damage of inner casings. The sample of conductor construction data used for this study is actually a 30-inch conductor. It's a surface casing of 13.3 inches, a 9-inch inner casing, and a production tubing of 3.5. So when it comes to the methodology, right, there are few types of loads on the conductors. Okay, weight of surface equipment and pipes, pipe axial stiffness, internal external fluids, drilling and installation sequence, pressure and temperature, well configuration, environmental loads, for example, wind, current, and wave. So as you can see here, first the NDT inspection of the edge conductors is being performed, and then subsequently the life extension requirement and specification. Then we have to calculate the global bending loads for operational and extreme conditions. And then we calculate the axial loads through the conductor for production and workover scenarios. You have two areas, which is actually the local defects, estimate local combined stresses at the defect location, generalized wall loss, which is perform conductor stability evaluation, and then you come with the risk assessment check for the surface casing. And this is actually done by structural reliability analysis. Once it's passed, then there'll be a risk assessment and classification. If it fails, then we need to do actually a conductor repair or continue operation by continuous monitoring and maintenance. Okay, so the most common practice of visual inspection and ultrasonic corrosion inspection are usually carried out as scheduled by operators to constantly monitor conductors. Measurements are taken at several elevations from the mean sea level to the wellhead, and special attention was paid in the splash zone, as this area is the most susceptible to severe corrosion. Remaining mean wall thickness is calculated, which indicates the average wall thickness of the conductor. Next, actually the analysis, strength and stability check. This method is actually we have adapted by Bow and Stahl, right? So the conductor casings were modeled as a multi-pipe in pipe. From the inspection data, the remaining wall thickness on the conductor at the splash zone can be divided into the minimum wall thickness and averaged wall thickness. So this strength and stability of the conductor are assessed using FlexCom, which is developed using elastic limit methodology presented in the IP guidelines, based on the theory laid down by Bohr and Stahl and subsequent publications. This assessment is conducted using the bending moments determined from the dynamic analysis and calculated axial loads as inputs. So for structural systems under combined axial compression and bending loads, it is necessary to check that the stress and stability of the system are at acceptable level. The strength and stability check results are expressed in terms of interaction ratios, which they are actually 8 in our check. So in stability check, we have actually 4, and strength check, we have also 4, right? Where an IR value greater than 1 indicates that the allowable design criteria are exceeded. So, okay. As you can see from this internal corrosion data for the 30-inch conductor. So this group of anomalies consists of conductor defects, which are exhibiting high levels of internal corrosion along 30-inch conductor casing length. Okay, ladies and gentlemen, these samples, right, we have taken case studies from from Peninsular Malaysia operations and also Sarawak operations. So FPMO and SKO. Yeah. So yeah, coming back to it. The first step in addressing the internal corrosion anomalies is to understand the effect of these defects on conductor strength and stability during storm and work over scenarios. This is done as per recommendations laid out by Bohr and Stahl for different strength and stability condition summarized in the table. Okay. So as you can see here, in this slide, it shows actually the external corrosion of a 30-inch conductor, which is actually labeled as the M06. Okay, and then we have the cracks. So this group of anomalies is characterized by severe levels of external corrosion and material degradation, perforations on the conductor casing. And an approximation for the wall thickness is made based on the UT reading and visually assessed quality of the conductor casing. The repair or mitigation will be recommended based on the strength and stability check outcome. If the corrosion wall loss is over a significant portion of the conductor length, a local spot repair may be possible. In such scenarios, recommendations similar to internal corrosion defects may be made for managing external defects. Okay. Results and discussion. Okay, on this slide, you can see we have actually taken a sample of a conductor or CC06 labels, internal corrosion. Okay, so by using the existing well inspection records performed on the well conductor, which is this CC06, the assessment is carried out and presented in this section. Okay, which was deemed high, medium risk as per the risk assessment. Okay, so as you can see here, on the elevation above the sea bed, at 28 meters, the wall thickness loss is about 22.7%. As it goes higher, where this, it is close to the splash zone area, as you can see here, 16, 18 meters, the wall loss is about 50 to 60%. All right. So what we have done here, what we have proposed is actually a sleeve repair for the internal corrosion. Okay. All right. Finally, the conclusion. So as for the conclusion, from the structural integrity assessment performed on the conductors, it can be categorized based on the strength and stability study on the conductor and surface casing corrosion effect on the structural stability of the wells. So the minimum mean wall thickness of the conductor can be used as a measure to determine critical loads on the wells. The critical remaining wall thickness and the wells typical loads have been calculated. So two types of structural risks have been identified, which are the higher risk category that needs to be repaired immediately, and high medium risk, which repair decisions depends on the asset life economy assessment. All right. So several UTA scan readings have provided information on the conductor wall thickness, which enables identification of the wells that need to be repaired. So the conductor which are categorized as high and medium risk have been repaired by adopting innovative rigless repair methods, as what shown earlier on the previous slide. So significantly reducing the structural risk and cost saving on the conductors. Okay, thank you, ladies and gentlemen. This ends my presentation today. I'm open to the floor for Q&A. Thank you very much for listening.
And his colleague, Muhammad, Suti Amrin, and Muhammad Akmal. As I'm Mr. Lagan, join us interested to ask any kindly together with address the discussion. We will post Mr. Logan and we will be emailing you back the answers. So let's us go to the fourth paper. It is by the title A Short Review, Numerical Floating Debris Migration, by Ms. Levine, Technology Malaysia, together with her team, Muhammad and Erwan Hafizi Kasiman.
Good day to the panels and also my fellow presenters. Today, I would like to present a short review on numerical simulation of floating debris migration. My name is Lavin Wong, and I am from University Technology Malaysia. First of all, I would like to introduce what is marine debris. Marine debris can be categorized into natural and also anthropogenic debris. Natural debris means that the debris comes from natural resources such as wood and log limbs. And anthropogenic debris, on the other hand, means that it comes from unnatural sources. For example, human waste, plastics, tires that you find at coastal areas. Predicting the source of marine debris is challenging as it causes pollution, and many countries are now looking into where the source of debris originates. And the development of numerical methods is important to improve accuracy of simulating migration of marine debris. In this paper, we're going to see the objective, which is to review works related to numerical modeling of floating debris migration in water channels. Numerical modeling of floating debris can be divided into Euler model and also the Lagrangian model. The Euler model is widely used in biology and chemical transportation. The advection diffusion equation can be seen in equation 1. The Lagrangian model, on the other hand, allows for backtracking of particles. It involves two techniques. One is the first technique is the particle trajectory is computed together with the velocity field. The second technique is whereby the velocity field is first calculated in advance, and later the input of particles are then released to track and let the particles flow together with the velocity field. Next, we will see into two different modeling, a larger scale, that is the oceanic modeling, and also in a smaller scale, which is the river modeling. Oceanic modeling, as you can see here, from past researchers, there are 4 researchers that have done, and there are more as well that have gone into this oceanic modeling. Leberton and Borrero used HICOM encoder and Pol 3D to simulate particles in North Pacific Ocean. This model is able to simulate long trajectory information of up to 30 years. However, this model lacks of inclusivity of wind variation or changes in sea level which might affect dispersion rate. Mansui et al., he simulate in the Mediterranean Sea using NUMO and Ariane. And this model covers a wide range, horizontal resolution of about 6 to 8 kilometers. However, the particles used in this model is reduced to a single concentration to reduce complexity. This model does not include degradation process, but biochemical process is also neglected. And because of this, it is not able to represent actual breaking of particles in the sea state. Critchell, on the other hand, used SLIM to simulate floating debris at the Great Barrier Reef region. His model includes the wind factor, but it does not include falling and rolling effect due to wind. Maximenko simulated at the coast of Honshu Island and simulated large amount of particles, which is about 400,000 particles, and include differential in wind motion. However, the special size of mesoscale eddies and the solution of the model he used is too coarse, which is about 10 to 25 kilometer grid size, and this is not applicable for detailed coastal area simulation. This is an example of how oceanic modeling is being carried out. First of all, there is the current eddies that will be simulated first, and comes later is the wind variation, and they will see the wind strays in different days that they're simulated, and later they will see how the migration of debris flows from one point to the next point. So oceanic modeling is able to simulate for a long period of time. It assumes marine debris floats for a projected period which is about 10 to 1000 years. Particles in oceanic modeling are commonly treated as dimensionless and passive. Particles is also generalized as a distinctive type, but in reality, these particles varies. An existing model can be improved for more reliable results. Next, we will see on debris modeling of river. Bocchiola used HICOM, Encoder, and POL3DD as well, and his model is able to improve that. Increase in debris rate increases bed shear stress and flow becomes shallower. However, the channels with small roughness and smooth surface may not be the case for rivers and oceans. Stockstill utilized the DEM model, and his model allows control over shape and properties of the objects. He models using spheres and disks, and he included the fluid drag, buoyancy, interparticle contact, and body forces in his model. However, this model is computationally intensive and only suitable for low concentration of debris. Rui Villanueva used iBird to capture effects of cylindrical debris and see the orientation and collision of these effects. This model also considers gravitational forces, frictional force, drag force, and fluctuations in velocity, which includes turbulence effect. However, this model may not be applicable for non-cylindrical body shapes. Vanderma uses SPH, smooth particle hydrodynamics, and simulated details in water impact, hydrodynamic forces, fluid motions of object entry and exit from still water. Just like the rest, this model is also computationally intensive and only limited to one homogeneous body. This is an example of river modeling that is used. First of all, they will validate the model using a straight channel flow and to see the different location over time as the debris flows from one point to another. And later, the position of this debris will be simulated and also be validated with numerical results. This is from Xiong et al. Debris modeling in river usually incorporates detailed processes of homogeneous debris. It is also only limited for very specific cases, just as mentioned earlier, either it is only treated as sphere or it is only treated as a cylindrical object. It is normally computationally intensive as it incorporates different kinds of physical processes from the debris itself, such as the drag force and also the collision forces. Existing models can be improved for better accuracy at larger spatial area, so that these models will not only be limited to such a small area, but it can be incorporated into larger coastal area. As we come to a discussion and conclusion, as we can see, as mentioned earlier, large-scale modeling is normally used for very large spatial area, which means that it does not incorporate the detailed processes of debris modeling, and it only focuses on passive particles or passive concentration of particles. Whereas for small-scale modeling, it only revolves around a very specific object. It includes different forces, but these forces will take a very long time to run. For example, if we want to find a missing body in the coastal area, it will not be practical if it takes months or weeks to run the simulation, to include all the processes, run the simulation, but it takes a very long period of time to understand how it flows from one point to another. Therefore, there is a need for more comprehensive model which are able to capture detailed physical process in a larger scale domain. Understanding these processes, understanding the migration of this floating debris is important to assist local authorities in reducing environmental impact around the coast. Not only that, it is able to assist in rubbish boom alignment, especially at the coastal areas, and able to reduce the impact of upstream debris from flowing into the estuary or the sea. So for this study, the authors would like to acknowledge the support of FRGS under the Ministry of Higher Education in Malaysia. We would also like to thank UTM for funding this study through the PhD Zamala Scholarship. These are the references used for this paper. That's all from me. Thank you for your attention.
Thank you very much, Ms. Levine Wong. It is very interesting topic because you are trying to monitor the movement of debris. Yeah, and that one is a way to control pollutions in the river and to have a clean river and estuary. Thank you very much. I enjoy listening to that. And we have two questions for you today, but it's a little bit related to GIS. Okay, so the question is about, is there any literatures that have utilized remote sensing or GIS for the debris modeling?
Okay, am I clear?
Yeah, your voice is very small over there. Maybe you can make it slightly higher, lower, higher volume. Okay, let's
All
give it a
right,
try.
let me try to
Yeah.
increase. Is it better?
You can give it a try. Okay, so the question is about, has there been any GIS effort or remote sensing effort to model debris?
Okay, regarding GIS, I think it's geoinformatics system, if I'm not mistaken. To be honest, I'm not that very sure. I believe so that there is GIS software to track the particles. Yes, but in terms of numerical, in terms of modeling the physics behind the particles, I don't think I'm not sure, but if I'm not mistaken, I don't think for GIS modeling they have come to that extent to model the physics behind the floating debris. Yeah.
Uh, well, somehow the second question was closer to your answer just now, because your model be integrated with GIS somehow to have a better of modeling be integrated.
I see. Okay, it depends on which, can I say, whether the compatibility of the model. For example, for example, for the review that I was looking at, it would have to depend whether the model is compatible with GIS, or is it a built-in Lagrangian particle tracking model. There are some models, for example, Telemach and Might. For example, these models, they do not need the GIS because the Lagrangian particle tracking is already embedded inside the model itself. Yes. So if you would like to incorporate with a GIS model, then I believe so that probably it would be more efficient if it's in a wider scale modeling. Yeah, where you have to have the type that is modeled by a different model, and then maybe
Mhm.
the GIS application can come along after.
Okay. Okay,
Mm-mm.
last one. There's also the one I took listing now that you can monitor where it flows to, and you can predict where it will be collected, where it will be accumulated. So they thought, is it practical to have floating collection site so that you can easily manage the river better? So
Yes.
it's like,
Mm.
yeah. So,
Yeah, so the whole purpose. Mhm.
yes, please, please.
Okay, so you mentioned about a whole collection site, correct?
Yeah.
That we could be able to see where the rubbish goes to, or even maybe a dead body floats and travels up to there. It's possible with the
Mm.
development of a model that is not too that's why in this review there is a two extreme, which is the oceanic modeling.
Mm.
Oceanic modeling basically is a very large scale model. It will look among the continents of the world to see where
Mhm.
does a rubbish travel from one point to another. On the other hand, there is also a small scale modeling that is the river, or they usually do it at the lab scale. So what happened to this model is normally it is only focused in lab because they want to look at the physics of, for example, rotational effect, things that are very concise, and this would cost the computational time of the model. So what we are doing now is to create or to simulate or able to put in the physics of the body, but at the same time reduce the computational time. And as you mentioned, this model is able to predict all these collective particles that maybe the rubbish would go there if we put it from a
Yeah,
source, for example.
that's right.
Yes. Mm.
Very interesting. You start from scratch on the physics, but eventually it can be put to police. Find the floating. Very good.
Yes.
Okay, last question. Last question. Maybe I give you around 1 or 2 minutes. Yeah, Miss Levine. Is there any characterization for your
Characterization, yes. So that's for now we are still looking into the easiest to model is actually spherical object, is to make everything into a spherical object and then to make it float and see where it goes. But at the same time, if the model is able to not only look at the shape, but it can also compute the characteristics that say the density of the object and also the different shapes. Maybe it's not only sphere, but it's also cylindrical, for example. And if we are able to add more character, let's say if you're able to
Mhm.
represent the physics of the body using
Yeah.
coefficient, yeah, I think that would be a
Okay.
breakthrough, because for now
True.
the physics is the hardest part to simulate because it takes a very long time to run. Yeah. So if there's a coefficient that we are able to, it may not be 100% accurate, but it's able
Okay.
to replicate the phenomenon, it would be a great help in terms of predicting slightly better way the movement of
Yeah.
this debris will go.
Yeah.
Mm.
Very interesting. Very interesting. I give you all the best to your research. Yeah, in
Thank you.
performing and getting a better equation to predict debris where it will float and eventually it stops. Where all the best to your research. Thank you so much, Mr. Levine, for joining
Thank
us
you so
today and
much.
Iccoee. Okay, ladies and gentlemen, that was the fourth paper for today. So now we are going to hear, we're going to go to the industry now. Okay. So we're going to go to the industry. We're going to go to Petronas. We're going to hear their work on managing a high pressure, high temperature pipeline. Detailed integrity assessment of deep water oil line displacement near continental shelf. So the team comprises IR Hayati Hussein, Azam Shah Jaafar, Muhammad Anwar Desa, and Muhammad Faisal Aziz of Petronas, Malaysia. So we shall listen to that.
I'm here to present a paper with title Managing HTHP Pipeline Detailed Integrity Assessment of Deep Water Oil Line Displacement Near Continental Shelf. I am IR Hayati Hussein from Petronas Group Technical Solution, GTS, Malaysia. This presentation will cover introduction, global buckling screening assessment, on-bottom stability analysis, uncontrolled buckling assessment, conclusion and recommendation, followed by future operational consideration. For introduction, let me share why this study was initiated. During routine underwater ROV inspection, an 18-inch oil pipeline was found to have moved from the support up to 3 meters. The apparent movement was located at rocky area near continental shelf having irregular seabed leading to various span rectification. Initially, the displacement was assumed due to increase of environmental condition, but since this location was only 20 kilometers away from the hot end, it was suspected that the pressure and thermal expansion may also significantly contributed to the movement. In view of that, we had performed detailed assessment to identify the potential root cause of the displacement. Was it environment or expansion that caused the displacement? We started by reviewing the screenshot of the survey. It appeared that the pipeline had unexpectedly moved to the side of the grout bed. As it can be seen on the picture here, there were cracks on the grout bed, although this grout bed was still supporting the pipeline. The most difficult part of the exercise was to study various survey information which was performed by different surveyors. Our first effort was to plot the survey coordinate on the same CAD file to identify any significant variation in the pipeline configuration. The support position as reported on the ROV inspection was used to match the survey information. Following correction of the survey information with ROV anomalies listing, displacement at other locations were observed and confirmed. More than 10 number of buckles were identified. The configuration of the pipeline on the seabed is illustrated on this line sketch. As shown here, there are 12 number of buckles were identified. The location of the grout bed are marked as Area 1, Area 2, and Area 3. As shown on this picture, the pipeline has been displaced 3 meters from the grout bed. Our next step was to perform global buckling screening assessment. We used the method stipulated in the NV F110. This involved estimating the soil restraint, the effective axial force due to pressure and temperature, and critical buckling force of the pipe body. The result of the analysis shows that 30 kilometer pipeline is susceptible to global buckling. To be more certain that the displacement was due to lateral or global buckling, we had carried out dynamic on-bottom stability. As shown in this chart, the displacement of the pipeline due to environmental load was not more than 4 millimeters. As such, the pipeline is stable and the environmental load is considered relatively low. Now that the assessment result significantly inclined towards global buckling, we decided to verify the integrity of the buckle by using uncontrolled buckling assessment approach and perform it using Abacus FEA software. The results of the analysis, as shown in blue color, were matched with the pipeline configuration from the survey on the red color. Once we certified with the match, the FEA result was assumed representative of the buckle. The final results are shown on this table. The ultimate limit state check for local buckling and fracture, as well as fatigue limit state results are all within the acceptable limit. Question was raised as to what was the cause for the grout bed to have crack in the middle and broke at the side. We had then performed a simple FEA analysis with the absence of the ineffective support. The result indicated that the vertical load acting on the grout bed was 2 times higher than the grout bed payload capacity. This explained that the grout bed was loaded more than it could handle that had caused the crack. From the study, we concluded that the pipeline movement was due to thermal expansion and pressure, which is effect of a HTHP pipeline. We believe additional assessment is required if any changes happen on the production. This may include detailed finite element analysis. Note that it is important to study the pipeline susceptibility to lateral buckling, especially for deep water pipeline, as the minimum ambient seabed temperature can be quite low. For future management of HTHP pipeline, we recommend when the pipeline is categorized as may be buckled during design stage, detailed design assessment on post-laid pipeline configuration is required. Suitable inspection program and method shall be selected to inspect the pipeline. We recommend for post-lay survey to be performed to identify any initial horizontal and vertical out of straightness that may initiate the buckle. Pipeline survey must be repeated if any of the following happen. Pipeline pressure reach the high trip setting. When there is block discharge and the pipeline pressure high trip setting fail to trip, and when the pressure and the temperature combination lead to effective axial force to exceed critical buckling force. That is all from me. Please read the paper for further detail.
Thank you so much, IR Hayati. How are you today?
Okay, Alhamdulillah.
Alhamdulillah.
Doing okay, yeah.
Okay, so it was a very nice presentation about pipeline at the Continental Shelf.
Yeah.
And it has moved, yeah, a little bit under HPHT, but also then contribution by the grout bag, yeah?
It damaged the grout bag, yeah.
It damaged the grout bag somehow.
Yeah,
Okay, so from this outcome of the analysis and assessment, did Petronas do something to repair the pipe, or what has been done on the physical body of the pipe?
Okay, right. Before we performed the assessment, actually, there was understanding that the pipeline had moved because of the environmental load had increased. Because of the span, because the pipeline had moved from the grout bag, it wasn't supported. So the span had exceeded the allowable span, meaning it may be subjected to buckle. Okay, maybe fatigue failure, because when a pipeline is subjected to environmental load and it dynamically move, it will have a risk of fatigue failure. So what we did earlier is that we already arrest the problem, meaning we already put the support. And because before I performed the analysis, I had suspected this is because of the buckling, we designed the span rectification such that it restrain also lateral movement. So we had rectified the pipeline from having lateral movement and restrain also vertical movement. So when we did the perform the analysis for lateral buckling, is only constrained to that kind of a shape of configuration. So we are not expecting to move that much further away from the location when we analyze it. Yeah.
Yeah. How long is that affected areas, IR Hayati? The pipeline, how long was it? Yeah.
I think because if you look at the configuration, there are span is about maybe 5 to 10 kilometer, and the remainings are also buckle. The first stop 20 kilometer. So the total length is about 30 kilometer. Yeah.
30
Yeah.
kilometers.
Yeah.
Okay.
So the soil at that location when we have span is mostly rocky area.
Oh, right.
Yeah, that is where before it go to shallow water. So and when you have rocky area, the pipeline start spanning and doesn't touch the seabed. In
Still
the area, the first
installation.
the first 20 kilometer, the buckle was happening on the clay area, so it's
Ah,
just supported.
I see. Okay,
Yeah.
very, very interesting. Very
Mhm,
interesting. And we have another question by Dr. Mubarak himself. I'm going to
mm,
read it to you, yeah?
mhm,
So it was mentioned that the finite element analysis and
mm.
actual finding of the pipe coincide. Was there any similar finite element study done during design stage of the pipe? So,
Okay, right. That is good question. Uh, some people misunderstood that when you done check the possible the pipeline might buckle, but they check the strain is acceptable. They did not perform uncontrolled buckling assessment. The uncontrolled buckling assessment means you do not rectify the buckle. You let it buckle, but the buckle will be remain acceptable, but you do not know that where would the buckle happen. If the buckle happen at the span, it will go out of the support. So that's what happened. So they did the assessment that buckle might happen, but they did not perform further analysis to check where would the buckle happen. So they cut short the assessment.
okay. So I wonder how is the pipe now? Is it okay? Any
Uh,
problem?
it should be okay, and it
Okay.
has been operated at slightly higher pressure. If you realize
Oh.
in the like higher flow rate, because if you realize the analysis just now result, we have
Mm,
two column. One is the current earlier operation product, and
mm.
the next one is with higher flow rate. Yeah.
So it's a very strong pipe. Hayati, despite all the challenges, is still
Yeah.
standing strong. Thank you so
Yeah.
much. Yeah, we
Right.
really enjoyed the discussion and we enjoyed the presentation. Thank you so much to IR Hayati and the whole Petronas team. They are here today. We are happy to have your support. Thank you so much. Yeah. So
Thank
let us
you.
hear now the next paper presentation. Yeah. Now where do we go? Okay. Now we're gonna go to. Hang on, yeah. We're going to go back to UTP, to academics listening. We're going to hear a paper entitled Numerical Assessment of Flow Around Circular Cylinders. So this will be presented by a team of, heading by Mr. Malakonda Reddy Lekala, Dr. Muhammad Latif, Dr. Do Kyun Kim, and Dr. Mubarak himself. So let's listen to the presentation.
Hello, my name is Malkunda Reddy and today I'm going to present numerical assessment of flow around a circular cylinder in transition zone. So the presentation outline is as follows: introduction followed with numerical methodology, numerical setup, numerical results and discussion, and finally with conclusion. So coming to introduction, like the dynamics of uh, flow around circular cylinders has been a very challenging task from decades due to the complexity of wake formation, and this wake formation is totally depends upon the Reynolds number. When the flow is passed over the circular body, it causes vortex-induced vibrations, which imposes the high cyclic stresses that leads to high fatigue damage. So, the flow regimes are categorized into different types based on the Reynolds number, and you can see on the table here. So, in this study, we are going to use subcritical, which is called transitional regime. So, numerical methodology to investigate the flow around the circular cylinder, we have used K-epsilon turbulence model developed by Lauderence Spadling, and here the Reynolds average and Navier-Stokes equations are used. One is conservation of mass and the conservation of momentum. These are the equations here. You can see on the slides where UI is like flow in either direction. That is like we have two directions as this is 2D, streamwise direction, transverse direction, where P and rho are pressure and density of the fluid. So numerical Bosni's relationship is used to compute the Reynolds stress component in terms of mean flow gradients and kinetic turbulent viscosity. and those equation is defined on the slides, and K is the turbulent kinetic energy and delta H is the Kronecker delta. The standard K epsilon model have two equations, one is for K and the other one more for epsilon. The turbulent equations for K and epsilon can be seen here, like, and in other words, those two equations can be defined as rate of change of K or epsilon plus transportation of K or epsilon by convection is equal to transportation of K or epsilon by diffusion plus rate of production of K or epsilon minus rate of destruction of K or epsilon. So this is like theoretical description of those two equations. Here where K and epsilon are turbulent kinetic energy and rate of viscous turbulent dissipation rate. So here we have 5 different constants used in this analysis, which are derived from the experiments. So open form, which is openly available for analysis, used to solve this. From open form we have a piece of form solver in this analysis, and low current number is maintained in to attain numerical stability, and the current number is defined as velocity into time step by minimum size of the cell width. Here current number plays a vital role, because when the current number is greater than 1, the properties of one cell transferred to the other cell. When the greater than 1, it moves abruptly and the numerical stability will be lost. So we have used for 600 numerical non-dimensional time steps for residual calculations. As a result, the time step significantly decrease here. So in this analysis, we have calculated different types of hydrodynamic coefficients, like such as the drag coefficient, lift coefficient, pressure coefficient, and Hall number. So this is we have used a rectangular computational grid to investigate the flow around the circular cylinder, and these are the dimensions of it. And we can see boundary conditions for inlet, outlet. Periodic faces are nothing but front and back faces. As this is 2D case, we have given empty boundary conditions for front and back. Cylinder walls, we have given velocity as no slip condition and pressure as 0 gradient. And top and bottom faces, like velocity free slip conditions and pressure as 0 gradient. So to solve Ram's equation, we have, as I said before, we have used K epsilon turbulence model, and K and epsilon are calculated by using these equations, where I refers the turbulent density, and again I is calculated 0.16 times Reynolds number to the power of -1/8, and L is the characteristic turbulent length, which is 0.07 times diameter of the cylinder we have used in this study. So this is the mesh generated, and we have used Ni, Nj, Nk refers to 3 directions, circumferential, radial and axial directions, but here we have used only, as it is 2D cylinder case, we have used mesh in Ni and Nj. So results and discussion for we have done convergence studies to obtain the optimal mesh size, grid size and time step. We can see, like, initially we have used constant grid sizes in streamwise direction. We have varied transverse directions, and you can see here, based on these transverse directions, as the length of the transverse direction increases, the effect on the hydrodynamic properties reduces and the values converge at one point. So from this analysis, we have used 5 times LC as the transverse direction length, and streamwise similarly 12 times diameter. So, and we have used same for we have carried analysis for optimal mesh size as well, and time step dependence as well. So the optimal computation domain for is selected as -3 times LC to the 12 times LC, and 5 times LC to the 5 times LC in, like, towards left and right directions. And the mesh size we have defined as 0.03 and delta T as 0.005. So based on the optimal mesh, optimal computation domain size, we have used time step, grid size and optimization computational domain. These are the we can see on the figure, this is like drag coefficient and lift coefficient. So, sorry, the drag and lift coefficient and Stall number and pressure coefficients agrees well with the previous experiments, and we can see these values agrees well with the previous experiments and numerical results that are already published. And this there is a slight difference might be due to this simulation setup. So now we are going to analyze the flow around the elliptical cylinder with a different angle of attacks and different different angle of attacks with the different aspect ratios. So this figure shows the flow behind the circular cylinder, vertical ellipse and horizontal ellipse at time step of 80. We can see for circular cylinder and vertical ellipse and horizontal ellipse here the flow behind the cylinders. So these are the streamlines for circular cylinder, vertical ellipse and horizontal ellipse at 600 time steps. The optimized flow domain is used to analyze the flow behind the elliptic cylinder with different aspect ratios for different time steps, and for different aspect ratios we can see how the flow behind the elliptic cylinders and the circular cylinder varies. So even this is a similar kind of stuff where for different aspect ratios with different time steps we can see this. Same goes to here 0.25, 0.5, 0.75 and 1.0. 1.0 refers as circular cylinder, and the other are like vertical and inclined ellipses. Conclusion: the flow around circular cylinder for more artillery Reynolds number was investigated. Open source CFD code which is available as an open form with the pressure implicit with splitting operators. Picoform is used to analyze the flow around cylinders. Due to the wavy flows operation along the spanwise direction, the wave width expands behind the cylinder, and this forms as complex nature. So, and we can see clearly as width of the ellipse reduces, the wake formation also reduces. Thank you.
Thank you very much, Mr. Melakonda. How are you today, sir?
Yeah, I am doing good, ma'am. How are you?
I'm good, thank you. So you have worked very hard on doing the analysis with the mechanics one by one. You optimize each element. So let's see now. If you want to bring back this innovation work of yours to the industry, what would be the optimum parameter or optimum design condition in order to minimize impact of vortices and or any failures caused by the flow. So what would be your opinion and suggestions, please?
Actually, coming to this presentation, basically, like I've used only single cylinder, but in industry, this will be different because we will have bundle of pipes or risers all together with minimal spacing. So I have presented only initial results in this paper. So, and coming next to your question, like, so we have different technologies or like methods to reduce the vortex-induced vibrations on pipelines or risers. For example, by attaching helical strakes or fairings or buoyancy modules.
Right.
So this is estimated that this will reduce the fatigue damage on the life of structure and increase the fatigue life. So what basically I'm going to study is like I'm going to use the principles that are studied from the nature.
Okay.
So it's like biomimetic. We are going to mimic principles from nature and apply those to our structures and see how this is going to affect the fatigue life of the structure.
Biomimic.
Yeah,
Biomimic.
yeah,
Yeah.
biomimic.
Okay, so that would be for any water bodies, ocean and as well as river flows as well.
Yes, I'm not sure about river flow. I have only considered ocean with flow speed, ocean flow
Yeah.
speeds.
Okay, that's
And
the scope.
of course, I feel like I imagine that both in ocean and river, the Reynolds number will be the same if the flow speed is equal.
Okay, okay. So I would imagine this would be good for offshore structures, any
Yes, ma'am.
circular shapes, bridge piers, yeah.
Yes,
So you're going to, with your design ideas, with your optimization and analysis, you are able to minimize any impacts
yes, ma'am.
near the circular cylinder. Yeah.
Yes. So it's like
Okay.
comparison between the circular cylinder and
Mhm.
biomimetic cylinders that we derive.
Okay. Do you plan to check, compare with some cases in the reality, or it would just be numerical for now?
As of now, it's a numerical number due to some limitations of experimental.
Yeah. But we can see there's a lot of work. There's a
Yes,
hard
ma'am.
work of yours. Okay.
Thank you.
So we really, it's a very interesting sharing session that you just shared with us. Thank you so much,
Thank
MK,
you, ma'am.
by the nickname of MK.
Yes, ma'am.
We are going to proceed now with the next paper. Yeah. Okay, ladies and gentlemen, so this is the last session for today for another paper, but I'm going to fly you slightly to our neighboring country, Indonesia. So the Indonesian Universitas Jana Batra, okay, so they will be sharing with us on how they look into the effect of underwater seal height against flow patterns in order to reduce sedimentation in navigation channel and basin. So it's a quite a long title, but it's like about how do we handle sedimentation. So the team comprises Ms. Tanya Edna Bhakti from Universitas Jana Badra, Indonesia, Nur Yuwono, Universitas Gajah Mada, Indonesia, Bambang Triat Mojo, also from Universitas Gajah Mada, and finally from another university, Ahmad Faramars Ghalizan, Institute Teknologi 10 November. Very interesting names, yeah. So without any delays, we're going to listen to their presentation.
Assalamualaikum warahmatullahi wabarakatuh. Bapak Ibu, how are you? I hope Allah will always bless us and give us the healthy condition. My name is Tania Etna Bhakti from Jana Badra University, Yogyakarta, Indonesia. I would like to present my topics. The title of my topic is underwater seal height against flow patterns in order to reduce sedimentation in navigation channel and basins. This is my presentation outline. The first, I would like to show you my research background and then my research method. And the third, we talk about the result, about the vertical profile of velocity current in horizontal direction. And the last, we talk about the conclusion. Bapak Ibu, in this slide, I would like to show you, as I tell you in the previous slide, I would like to talk about the research background. This picture, when we see this picture, this is, we call it jetty. Jetty is a structure extended perpendicular to the shore in order to get sufficient depth of the port basins. But this kind of structure has some disadvantages, especially when jetty located in surf zone. This is, we call it surf zone. About the definition of surf zone, you can see the detail in my paper. Yeah. Sedimentation problem will occur in this area that causes longshore current that drives sediment transport. To solve a sedimentation problem, particularly the port that has been operated, there are some alternative solutions. For example, we extend the jetty out of surf zone, and the second, we can maintain dredging, and the last, we can use breakwaters to cover that area to protect that area from sedimentation problem. We know that every solution has advantages and disadvantages. For example, when we choose to dredging, the dredging will interfere with port operations. And when we choose to extend the jetty and construct breakwaters, it will be costly. One of our solution, we give another solution. Yeah, for example, we install underwater seal. This is underwater seal. You can see this underwater seal, the black one here. UWS, or we call underwater seal, or I will call it UWS, is a submerged structure installed around basin and navigation channel. It will protect this area from sedimentation problem. Okay, in this slide, I would like to show you my research method. I do the research. The physics model research is conducted in hydraulic hydrology laboratory at PSIT, Gajah Mada University. I use field flume. And for measuring current velocity, I use downlooking ADV, acoustic Doppler velocimeter. This is my method to get the data from the current. This is I use this map to get the data from. Okay. This is this part why I choose the flume to do my research, because 2D physical model test is made to simulate the UAS in controlling steady uniform flow. So in this case it is expected to represent the current along the coast. The method the model test is carried out in the glass flume. For the detail of my research, you can see in my paper. Okay, in this slide, I will show you the distribution of vertical velocity in horizontal direction without WS structure is theoretically determined on the base of the flow characteristic of steady uniform flow. Using the theoretical current profile of or without UWS as the reference of current profile of channel with underwater seal. So the curve is made this kind of curve. So we can see the differences between the profile without UWS and the profile with UWS. The pink one, the pink curve show that current deflected as the result of the WS structure existence in this channel. This is the channel. And in this slide, this is the result of vertical profile of velocity current in horizontal condition. I do with the H per D. H is the height of underwater seal, and D is the depth of water. The comparison about the depth of water and the height of underwater seal. This one, first picture, this one is the rectangular, this one is curve, and this one is trapezoidal, and the H per D is 0.1. And the second picture, you can see this is the current profile of with UWS H per D 0.3. And in this slide, I would like to show you the comparison. The H per D for 0.4, H per D 0.6, and H per D 0.9. You can see the based on the theoretical, it be concluded that the lower layer, the current is deflected by WS structure, and the lower layer, can pass the WS structure. The higher WS, the better capability of WS in deflected of current. This is also that the current deflected the result, yeah, current deflected by WS structure. Yeah. Uh, in my previous slide, in this slide, I state the higher WS, the better capacity of WS in deflected the current, but it is not 100% right. Correct. Yeah, I mean correct. Because the conclusion, I will show you the conclusion. The conclusion will let me do the next research, yeah, connected with this research. I do with quasi dimension, yeah, about the conclusion, the WS structure, which is too high, is less effective in deflecting the current. Why? It reminds that sediment distribution in the upper layer is suspended load and the lower layer is bed load. The function of WS is to protect the area inside WS from bed load, while suspended load still pass through the top of WS and will be deposited in the basin and navigation channel. So WS is when we install WS, we still need to maintain the area, the navigation channel and basin area. We still have to maintain. In next my research, I would like to try to find the height of the effective height of WS that can protect navigation channel and basin from sedimentation problem. Okay, Bapak Ibu, this is my research. Thank you for your attention. Terima kasih. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullah. Apa kabar, Bu? So, welcome to Malaysia.
Yeah, Alhamdulillah, I'm fine. Alhamdulillah.
Alhamdulillah. It was very nice presentation you had, and
Yeah,
it
thank
was a
you.
very big flume of research. You have conducted your experiment in a very big flume. We like it
Yes,
so much.
yes. We use
And the
wallpaper.
idea,
Yes,
yeah, the wallpaper, the last one, I saw that. And the idea of putting underwater seal
yes,
to control sedimentation
yes.
is a very smart one. I like it. I like it so much. Okay. So I have one question posted to
Yes,
you. Okay. Oh, so you already answered that, yeah? Which
yes,
scaling method you
yes,
use for the sediment transport?
yes,
So
yes.
you already
We have.
answered that one. So okay, now I have another question.
Yes,
How you got this nice idea to have something hanging in the
yes,
form of underwater seal in
yes.
controlling sediment? How did you trigger this idea?
Yes.
Yeah.
Uh, I read from another paper from Pak Rahman Hidayat.
Hmm.
He was S3 at I forget Japan in Japan.
Okay.
Only two underwater seal in this around the world. Only two.
Mm,
First underwater seal is in Kumamoto port, and the second one
okay.
is in Indonesia, at Tuban Gresik. Tuban Gresik.
Okay.
Yes, only two. Uh, we can use the underwater seal maybe only for the jetty that was installed. It means when we have to construct jetty, it means we can make the long jetty.
Okay.
Yeah, instead
Yeah.
of
Yeah.
the space between the shoreline and the birds is we have to make
Yes.
the long jetty. Yes.
Yes. Okay.
The idea of underwater seal is I think the idea to put underwater seal is only for jetty that was installed uh, in the
Okay.
port. Yes.
Okay. So it is like a repair or mitigation.
Yes, mitigation, mitigation from the
Okay.
sedimentation.
Okay.
Every sedimentation will apa ya, intro apa ya, mengganggu apa?
Disturb.
Yeah,
Disturb.
disturb. I'm
Yeah,
sorry,
yeah, yeah.
disturb.
No,
Yeah,
it's good. It's good.
will
Okay.
disturb the activity at the port. Yeah.
Okay.
So
Yes. Yes.
yes, so we have to put the underwater seal to
Mm,
surround the navigation channel and
okay.
yes,
Okay. So to the ladies and gentlemen, so whenever you put a structure to disturb the flow will behave differently. So
yeah.
from there, the sediment will be brought in a different manner as well. Yeah. Yeah, Ibu?
Yeah, yes, the bed load with deflected
Mm,
to another place, but the suspended load still overflow the underwater seal,
okay. So
because the higher underwater seal, I think it's apa apa tidak ada gunanya. What is
no use. No
no use?
use.
Yes, I'm sorry.
Okay. No, it's
No
good.
use.
It's good.
Yes,
It's good.
yes,
So,
no use. Yeah, yeah.
uh, but the
So
bad load will go somewhere, isn't it?
yes, we have to deflect it. So
Mm,
the bad load will not
mm.
apa
Disturb.
come into
Okay.
the
The-
navigation channel and the pond. Yes,
So you are clearing the navigation channel, yeah?
yes,
If it's
yes,
too much, then the boat cannot come in, isn't it? You're going to disturb the navigation lane. Yeah, so I
yes,
understand now. It's good. It's good.
yes. We cover every navigation channel
Mm,
and the pond. Yeah, the pond. What pond
okay.
was yes,
Very good, very good. I hope one day you can place it near the Indonesian areas for
yes,
a big scale study over the
yes,
long time. Yeah, yeah, Ibu.
yeah,
So
yes,
perhaps one day. So no worries.
yeah,
If then we can just visit Indonesia to see
yes,
the success stories of yours.
yes, yes,
Okay. Thank you so much, Bu. Thank you
yeah,
so much, Bu Tania. We really enjoyed
yeah,
this session, but we have to listen to another story from
yes.
another Indonesian university.
Ya,
Okay? So
oke,
thank you
thank
so
you.
much.
Assalamualaikum
Assalamualaikum.
warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, ladies and gentlemen. So the last paper for today, before we end, would be coming from Universitas Katolik Parahyangan Indonesia. So we're still in Indonesia, but don't forget to come back. Okay. So the title of the paper is Tapping the Potential of Shallow Water Model for Wave Simulations. So it will be headed by Mr. or Pak Bobby Minola Ginting and Dodi Yudianto and Albert Wicaksono. So all of them are from Universitas Katolik Parahyangan Indonesia. So let's listen to their stories.
Hello, everyone. Thank you for the opportunity for us to present our work entitled Tapping the Potential of Shallow Water Model for Wave Simulations. My name is Bobby Minola Ginting from Civil Engineering Department, Parahyangan Catholic University, Indonesia. So we know good understanding of water wave characteristics is very important for designs of coastal and offshore structures, as well as for hazard assessment and mitigation efforts. Studies on water wave characteristics, we know they have been performed using Business type equations models. In the past decades, these models have been extensively used, and we know these models can also be considered as an extension of the original shallow water equations. These models are of high order approximations. That means they are quite accurate, or let's say very accurate, but quite expensive. So the idea of this work is that we would like to propose a new approach, a simpler yet robust approach using non-hydrostatic shallow water equations. Well, I will show you the comparison at a glance between the proposed approach and the Business type equations. Well, the main difference here is on the pressure term here. As you can see here, the pressure terms in our model in non-hydrostatic shallow water equations account for the pressure at bottom. So we symbolize with PB here, and it includes a continuity equations here. So that means we need an iteration procedure. So if you see here in the Boussinesq type equations, the pressure term here is replaced by high order approximation. So let's say it is more complex, yes, but probably I will say it's a bit more accurate, but we will show in the end that our model can maintain the accuracy of the Boussinesq type equations models. So we will not present the computational details in this work, but I would like to show you my recent work that can be downloaded under this DOI. It's about the extension of artificial viscosity technique for solving 2D non-hydrostatic shallow water equations. Well, this is the benchmark test that we use in our work. This is the tsunami solitary wave on a conical island. This is a laboratory case performed in 1995. So you can see here is 25 multiplied by 30 meters basin. On the left side here, well, the boundary conditions are set as a solitary wave with, this is the water level equations you can see here. And on the left side also, we give the velocity in x direction with this equation, and the velocity in y direction is set as 0. So you can read this paper, the original paper, for the detail of the laboratory case. This is our numerical results that we perform using non-hydrostatic zero water equations. You can see here, our model can capture, the collision of waves behind the conical island here. And you can also see here, there is a wet-dry mechanism on the conical island that can be modeled as well accurately by our model. Well, we present also here the capture of the wave propagations from 9 seconds until 15 seconds. This is the detail on the conical island. If you see here, you can clearly see here the wet-dry mechanism on the conical island that has been accurately and stably simulated by our model. Well, we also present here the detail of the wave propagation from 9 until 15 seconds. Here we present the comparison between the result of our model non-hydrostatic shallow water equations versus Boussinesq type equations. Well, if you see here, yeah, I will say that, well, our model can compete with the high order Boussinesq type equations. For example, here you can see between 10 until 12 seconds, yes, Celeris is the Boussinesq type equations models. Celeris can capture the wave more accurately as we do, but for example, on P22 near behind the conical island, you can see here our model can capture the wave more accurately than does the Celeris. So that I will say here, our model can compete with the Boussinesq type equation models. So let me conclude our work that first, our numerical method that presented in this work is suitable for the applications of non-hydrostatic flow. That means it would be suitable for general water wave equation or water wave problems. The second one is our model accurately computed the results when dealing with shock wave and wet-dry problems, as I have shown near the conical island. And also behind the conical island, that the collision of waves are accurately and stably simulated. Well, the last one is this work also revealed that the non-hydrostatic shallow water equations models can compete with the Boussinesq type equation models in terms of accuracy. So it will be interesting to develop the non-hydrostatic shallow water equation models in the future. Thank you very much.
Okay. So, ladies and gentlemen, that was the closure of our session today. A very detailed, comprehensive fluid mechanics paper trying to compare against another established equation, Boussinesq equation. But unfortunately, we are still trying to locate. Still trying to locate the presenter. The presenter is having a connection problem because he himself is in Indonesia. But we have several questions asked by an expert in fluid mechanics himself, Dr. Muhammad Latif. So I will read them for you. So is this using a single layer of fluid? What is the shortest wave this can resolve? And how does it differ from another model of swash? Okay, we will be keeping these questions. We will be delivering them to the presenter, and we will get back to the answers to you by email. But should you have any more questions for this session, you may list them down in the given chat box or in the given live Q&A chat box. Okay. Um, so for the sake of time, time shows 6:50 are officially finishing our session. Session 2 on on the theme of advanced coastal and offshore engineering. As representation of my team, I'm the would like to thank deeply to all presenters, the participants who have been closely supporting for the session today. So we expect to have you again and the day after tomorrow until the end of the event of ISKCON. So with that, I thank you very much and have a good day. Assalamualaikum.